Now, Introduction to Quantum Physics, Part 3, Bohr's Model. So, there are four important postulates for Bohr's model. This is very, very important. Please do it nicely. So, what does the Bohr's model say? Electrons revolve around nucleus in a fixed circular paths. Okay, or I can say that orbits, they are basically the stationary state. Okay, orbits are in the stationary state, and if they are in a stationary state, they will have the constant energy and radius. Okay, so this is my first statement of the Bohr's model. Electrons revolve around nucleus in a fixed circular path. You all know that. Suppose this is my nucleus, and now it's the first orbit for the electrons, second orbit for the electrons, third orbit for the electrons, and let us say the fourth orbit of the electrons. Okay, so okay, it's not nice. Okay, this is the fourth orbit. So let us say this is n equals to 1, this is n equals to 2, and this is n equals to 3. Okay, and this basically in this direction the electrons are moving. This is one electron, this is another, this is another, and I can say n equals to 1 equals to ground state. Okay, this is the ground state, and electrons are moving. And what does the first say? Electrons revolve around nucleus in a fixed circular path. Okay, now the second one. Second statement is orbit of an electron does not change unless energy is added or removed. Okay, that means electrons never change its orbit. It depends on the energy that we are releasing more energy or we are taking the energy back. So if we are adding energy, okay, what will happen if we are adding energy? That means electrons jumps from lower orbit to higher orbit. Okay, it's very simple. If we add energy, electrons will jump from lower orbit to higher energy. And if we lose energy, what will happen? Electrons jumps from higher to lower n. Okay, so this is the second statement of Bohr's model. Now the third one. Wavelength of radiation emitted by an atom depends on the energy difference of the initial and final orbits. Okay, so wavelength of radiation emitted by an atom depends on the energy difference of the initial and final orbits. Suppose if I need to write it mathematically, how I will write? So I will write hc by lambda equals to E final minus E initial. Okay, or I can write 1 by lambda equals to 1 by hc E final minus E initial. I can write it like this way as well. Okay, where h equals to the Planck's constant, I have discussed earlier, you all know that, and c equals to speed of light. Okay, so this is the third statement. For this, angular momentum of an electron is quantized. Okay, suppose this is this is basically a nucleus here, the electron is here, and this is the radius, and electron is going in this direction. So momentum of an electron is always quantized. That means we can just find the value. There is some value. So it is L equals to mvr equals to nh over 2 pi. You need to remember this, and where n equals to integer. Okay, this is the fourth statement. And always remember, for hydrogen atom, allowed energy levels, the formula of allowed energy levels for hydrogen atom is En equals to minus 13.6 electron volts over n square, where n equals to 1, 2, 3, any value it can happen. Okay, so let us revise all the four. The first one is electrons revolve around nucleus in a fixed circular path. You can see here there are the fixed circular path. Second one, electrons, if we add energy, then electrons jump from lower to higher n. If we lose energy, then electrons jump from higher to lower n. Third, wavelength of radiation emitted by an atom depends on the energy difference of initial and final. So wavelength, we all know hc by lambda, or 1 by lambda, we can say 1 by hc, E final minus E initial. And last one is angular momentum of an electron is quantized, and mvr equals to nh over 2 pi, where n is the integer. These are the formulas we need to remember for this. Okay, so let us solve the question number first for this. The question is, what is the energy of a photon that when absorbed by a hydrogen atom could cause an electronic transition from A part n equals to 3 to n equals to 6 state, B n equals to 1 to n equals to 5, C n equals to 2 to n equals to 4 state, and D n equals to 3 to n equals to 4 state. Okay, so I'll solve the A part. B, C and D are your homework. So if n equals to 3 to n equals to 6, and what you need to do, what is the energy of a photon that when absorbed by hydrogen atom could cause an electronic transition. Okay, so n equals to 3 to 6, we know delta E equals to E final minus E initial, or maybe E higher minus E low, whatever. And we know what is the formula of En, minus 13.6 n square EV. Okay, in the fourth point of Bohr's model, I have discussed this formula. So what will be E final minus 13.6 by, what is, see, it is moving, see, n equals to 3 to n equals to 6. So n equals to 3 is the initial state and 6 is the final state. So it will be 6 square minus 13.6 over 3 square. Okay, let me solve it. Okay, let me solve it. This is 13.6 divided by 36. So it is minus 0.38 plus 13.6 divided by 9. It is 1.51. So basically 1.51 minus 0.38. So it is 1.12. So that is the difference in the energy here, joules. Okay, so this is the answer for A part. Please remember the statement. It can be asked the electron is in fifth state and initially it was in first state. So you need to find out what is final and what is initial. Okay, so you can please find out B, C and D part using the same formula. Thank you.